Assume the readings on thermometers are normally distributed with a mean 0 and standard deviation 1. Find the probability that a randomly selected thermometer reads greater than negative 2.04. So first we have sketch. So greater than negative 2.04 would be this one. Greater than means to the right of it. So and this probability can be done by StatCrunch, greater than negative 2.04. So we go to StatCrunch. Remember, it's stats calculator normal. Stats calculator normal. Mean was 0, standard deviation was 1. And we wanted the area to the right of negative 2.04. So to the right means you do greater than or equal to. Point 9793. So Z alpha denotes the Z score with an area of blank to the right. So their convention is that if they have a subscript here, if they have the subscript alpha, then it means that alpha is the area to the right. So if the area under the standard normal curve to the left of negative Z equals negative 1.72 is 0.0427, then what's the area under the standard curve to the right of 1.72? So you know that the normal curve is symmetric, and whatever we'll have on the left of negative 1.72, so let's look at the picture. So because of the symmetry of the normal curve, let's draw. So let's say we have 0 in the middle. We have negative 1.72 here. And this is the area to the left of negative 1.72. And they were asking how much area do we have to the right of 1.72. So 1.72 is here. Therefore, by symmetry of the normal curve, we'll have as much area to the right of 1.72 as we had to the left of negative 1.72. So it's the same area as 0.0427. If the area to the left of a z-score is less than 0.5, what must be true? So on the normal curve, the total area is 1. Let's look at this normal curve, for example. The total area, this total area is 1. And they are asked, and if you do a midpoint, so the midpoint would be 0. So let's draw another one. So the midpoint is 0. So half of the area is on the right of 0, and half of the area is on the left of 0. So they were saying that if the area to the left of a z-score is less than half, then what must be true? So what must be true is that that z-value must be negative. So you see from the picture that if the z-value is positive, this is a positive z-value, then the area to the left of it, all this area is more than a half of the total area. But if you take a negative z-value, then the area on the left of it is less than half of the total area. Remember, half of the total area is from 0 on either end. So whenever area to the left of a value is less than a half, then that value has to be negative.